Well, hello everyone. Welcome back to Adrian's Digital Basement 2. Today is a super mini mail call episode. Let's get right to it. It actually says open other side, which I guess I should follow the directions. I typically open on the bottom because I don't want to show the personal information on the labels. Oh boy, we have more Minnesota goodies. The maple bun, a nut goodie. This is awesome. More nut goodies. We have the vanilla bun and another one. We got a motherboard here. All right, here is the letter. Adrian, greetings from the southern tundra of Minnesota. as is in flyover country, as one of my other viewers said. Enclosed, please find the Apple IIe parts that we emailed about earlier. That's right, I remember chatting about that. I've included an Apple IIe unenhanced motherboard, including a full set of Apple branded DRAMs, very cool. An Apple 80 column card, also unenhanced, meaning it has no 64K memory expansion on board. Supposedly this card only works in this version of the motherboard. In the bag here are all the parts. I could strip off the old case successfully despite my best efforts. Most of the knockout covers broke instead of flexing enough to come out cleanly, so only one is included. If you know how to get those out without breaking them, there's a video right there. And then we have one Dynacomp PSU model 606-5001 with cord. Since I had my tools out to strip the case, I opened the cover off the PSU, and sure enough, it had Rifas installed, but the inside of the PSU is clean and all the caps I see are in good shape. Two caps I couldn't see, but they have electric tape on them for some reason. I fired up this machine while everything was still in the original case and it ran the diagnostics, everything worked. I hope it still works after shipping. If not, everything is socketed on the board, which could aid your parts bin at worst or make it a simpler fix. Indeed, these boards are so reliable, I'm sure it's still fine. I've included a selection of goodies right here, as they seem unique to my area, though I'm sure they're not, as they're sold on Amazon. I commend the entire contents of this box to your care and feeding. Please share anything unneeded or unwanted with the rest of the community as suits you. Please keep up the good work. Even though I'm primarily interested in Apple II content, most of your other videos are just as fascinating. Your subscriber, Fred Flintstone. All right, well, thank you very much for that. All right, look right here. These are those little broken covers that he mentioned on the back of the Apple IIe. Yeah, so indeed, these things get so brittle. I thought the key was, like the top here, you just poke it on the inside, it just pops out. Not too sure about that. But it looks like we just have feet and screws and other things. So if I recall on this machine, why there's not the whole computer, but just parts, is the case was damaged. So that's why we have the motherboard and stuff like that without the rest of the case. All right, so here's the motherboard wrapped in aluminum foil, which is awesome. It does actually provide some protection. I mean, I couldn't say for sure, but I really think that is the case because it kind of shorts all the chips together, so it helps void any kind of static that could build up and cause some damage. So there it is, Apple IIe motherboard, an unenhanced version, so MT DRAM. But it has the Apple logo on it, so does that make it better somehow? I don't really think so personally, but you know, you never know. So there's a power LED here, and then there's another LED over here. I don't really remember what this one here does. We have the expansion slots, and unlike the Apple II Plus or the Apple II, it doesn't have slot 0 on it, which was always used for the memory expansion card, which of course is built into the chipset on this. So that slot is just gone entirely. The RAM expansion in the 80 column card plugs into this, which is the auxiliary connector. Typically 80 columns card was in slot 3, but Apple kind of cloned the functionality of that and put it here in the auxiliary slot. The later IIes, the enhanced version, if you're not familiar, basically had 128K of RAM, so 64K on the motherboard. And even with the 64K actually, some of this is bank switched because the ROM takes up the space in the upper part of the memory, not to mention there's IO space that is used. So Apple bank switches this memory exactly like it did on the Apple II and the II Plus in that slot 0 card, which is, you know, integrated into the motherboard. But then on the enhanced IIes, just like on the 2C, there's a card that plugs in here, the 80 column card, which I think is included here. Should be, it's probably right here. That has the actual extra RAM on it. It has another 64K of RAM, so it's like shadow memory, and it's bank switched in as well. So it's all a whole bunch of bank switching, but of course, because it's all standardized, all the software supports it. All right, so that's the motherboard. Everything looks good. Let's take a look at this video card. And there it is, the Apple IIe 80 column card. Just has a couple ICs, I guess some kind of a ROM there, and that's it. Why this isn't integrated into the motherboard exactly, your guess is as good as mine. Does anyone know why Apple didn't just put this on the motherboard? I really don't understand. It's like, it's so few ICs, but I suppose maybe they thought they could charge extra for this, but I think it was just included with every Apple IIe in the end. I can't quite remember. The way it goes into the slot is like this, and you can tell because there's a little notch cut in the PCB there. See that, like that? And that's because the case itself, the Apple IIe case, curves towards the keyboard. It kind of slopes down, and that is for clearance, that is like that. Often on the Apple II, if you have longer expansion cards, they also have that kind of notch cut in them to follow the slope of the case. So that's a way that you can tell which way these cards go in. So that goes in just like that. All right, so here is the power supply. It looks like the little RF shielding strip was included here. Apple computer there, 6006-5001. There it is on the side, made by Dynacomp in Richardson, Texas. It looked from 1983. I think Delta also made power supplies for the Apple II. Very reliable. I really haven't had many issues with these. The only problem is, of course, as was mentioned in the letter, you have to be very careful about those Rifas. Well, because unfortunately if they blow, and I think you might have seen videos on the channel where that's happened while I had it on, they let out the magic smoke and it stinks and it fills up your room and everything. So I highly recommend, if you have an Apple II, even an Apple II GS, because some of those have it, you should open this up and try to get those out. Oh look, the mounting screws are included on the bottom. That's how nice. That's what screws it into the bottom of the case. All right, well, I'd like to power this machine up. So I am gonna take these screws out and we are gonna fix this Rifa situation once and for all so that this thing will be safe to use in the future. So I'm removing all the screws that are on the side here. There are a couple rivets here. Don't worry, don't let those fool you. I don't think you need to worry about those. I think when we take these screws out, this whole bottom cover here where these 4 screws are will come out, sort of revealing what's inside. And these rivets just hold the kind of bent metal together. Okay, there we go. So this should pop out, if I recall. There it is. Alrighty, there it is. A very early switch mode power supply. I mean, early as in the Apple II, when it came out in 1977, had a switch mode power supply, you know, very similar, if not this exact design here. And that was pretty ahead of its time. If you think about machines like the Commodore PET and also the TRC Model 1, those had linear power supplies. So like a big transformer and a bunch of regulators and made a bunch of heat. This was a much more efficient design right here. So the Rifa cap, there's one there and there's one right down there as well. I don't know what the deal is with this electrical tape on here, but whatever, it's fine. This PCB here is held down by 4 screws. There's 2 there and there's 2 there. And I think if you take them all out, you can kind of get this, kind of wiggle it out of the case here around the AC mains input here and stuff like that. So that is what I'm gonna do to get to the bottom. Now, while I'm doing this, I'm gonna talk a little bit about those Rifa caps. So they're almost always set up as input filtering. So basically, they are used, I'm just trying to dump the screws out here. Do I have them all? I do indeed. There we go, all 4, okay. So they are used to filter the mains. Now, from my understanding, and I'm no expert here, they're not used to filter the power going into this. It's for filtering the power that goes out of this. And I know you're thinking like, what does that mean? Like, you know, this is using up power, it's going in. Well, if you think about what this is, it's a high frequency switching power supply. So instead of running at 60 hertz like a normal transformer would with a power supply, this runs at a much higher frequency. What happens is the power comes in, it's converted to DC, it's filtered through these caps right here, and then it uses a transistor, which is under this metal cover here, to chop the signal. So it basically creates a new AC waveform, which then feeds into this transformer. And then the frequency or the duty cycle of that waveform that it's creating, this transistor here, can then regulate the output. So the output of this is nicely regulated. The problem is this might be running at, say, 50 kilohertz or 10 kilohertz or whatever. The frequency that this is switching at is relatively high. And the higher the frequency, the smaller the transformer can be. That's one of the reasons why these are very useful, is because it reduces the overall weight and size of the transformer. But the noise that's put back in the AC line, especially back in the old days, could have a detrimental effect on other equipment or whatever in your house. Plus there's like RFI emissions and stuff like that. So on the input side, there's usually some inductors and some filter caps to help filter that stuff out, just for emission standpoint. So it's really there for like an emissions thing, like for a regulatory compliance thing. It's not really necessary for the power supply to work. The reason why the Rifas can blow is because they're usually installed across the live and the neutral line that's on the mains input. So they are always seeing the entire voltage that's connected to your mains input, which of course here in the US, 120 volts or so, at least at my house. Oops, I'm trying to take these, the nut off there so I can slide this out a little bit. There we go. And unfortunately, when the Rifas start to fail, they start to fail with really low resistance. So normally a capacitor, it charges up and then that's it. It doesn't really show itself as a resistor. But when these start to fail, they start to act like resistors, which of course, you plug a resistor across your mains input, well, it's gonna get really hot. And that's what happens. And then what happens is they start to get hot and then it's a cascade failure. And then they start to get really hot and then they let the magic smoke out. So I'm trying to figure out how to get this out of here. So with this there, it should be able to lift up, but it's not really super easy. I think I'm gonna have to take this power cord out on this side, and that will allow me to lift it out. But these stupid things are always super hard to get out. There's a special tool that exists to kind of clamp onto this and get that wire. It's like a grommet, right, that holds these cables. And if you don't have that tool, it can be extra hard. Typically you can grab it with something like these are like my strippers here, wire strippers on the inside, and you have to kind of push it through the hole here. All right, there we go. I was able to sort of twist it, and now this came apart, and notice that the cable came out, and now I can lift the entire PCB up. I can't get it out entirely because it's still soldered to this stuff when they assembled this thing, but it should be enough, hopefully, maybe, come on. It looks like it's still holding on right there at this nut. Okay, how about now? Does this come out a little bit better? What is holding this in? Oh, there we go. Okay, so there it is. There's the underside. And then here are the two Rifas. So 0.1 microfarad X cap and 0.1 X cap. Now, it's got two of them. Let's see if we can figure out how those Rifas are actually used on this power supply. So this one here is connected there to, looks like the neutral. And then this connection point here is the live, that's a black wire, and it goes through like a thermistor or something right here. And then it's connected to this Rifa. So this Rifa right here, that one, is actually connected right between live and neutral. So that's a prime candidate to let go. Now this other one down here, there's another one right there, the screwdriver is on it. Let me see if I can figure out how that one is connected. Sometimes, unfortunately, Rifas, which are X safety caps, are connected between the ground or earth and live. And that is completely, I mean, I guess in '83, then maybe that was okay, but it's not okay anymore. You should only ever have Y-class safety caps connected between the earth or the ground and live. I mean, that's not uncommon to have that, but a Rifa should not be used that way. So this is the other Rifa right there. It's those two pins. This pin here is connected to this. This pin here seems to be connected to, I guess, the live, but through an inductor. Okay, through an inductor. And the other side goes to there, to here. What is that? It's kind of going over to this. Looks like it's connected to one of the legs on the bridge rectifier. So I don't know, something to do with the DC side of things. Either way, I need to remove both of those. I'm taking them both out. And I have a little selection of replacement ones here. These are 0.1s, so these will do. They're a little bit smaller now. And these aren't the old paper ones, so they're not gonna cause an issue like these Rifas will. And rest assured, if you have these on your board, these types of Rifas, they will fail. It's just a matter of time when that happens and you're gonna have a big old smoke show. And if you're replacing these, what is very annoying is that they often bend the leads over, which makes the desoldering process that much harder. And there we have it. There is a Rifa cap that has not blown, but it will shortly. And you notice it's starting to look all sort of cracked and everything. As it gets hotter and older, it will get worse and worse until it lets out the horrible, stinky magic smoke. And then to reinstall these, you can either bend the leads with like little things like I just did there, or sometimes there's actually different spacing on the board, depending on how it's made. And I actually bent these unnecessarily because I see that there is the smaller spacing on here already. There we go, one of them has been replaced. Let me just quickly do the other one. I did forget to mention, if you are opening up a switch mode power supply like this, please make sure that before you do that, you let it sit a while, or you, when you do open it, you need to discharge the main DC filter caps, which are these large ones here with the tape. Because those can have, in Europe at least, like 400 something volts on them. You can get a mighty good old shock from those. I haven't plugged this thing in. It was being shipped to me, so who knows how long this has been since it's turned on, but probably a month. Capacitors are not like batteries. They don't hold their charge indefinitely, so I wasn't worried about that. But just keep in mind that that is something that you need to do if you are working on a Rifa cap replacement, or any recapping for that matter. You need to make sure that you don't touchy the parts of the power supply that can give you a little bit of a zap. All right, there it is. There are those two new Rifa caps. They are replaced. There are the inductors. Everything else on here looks fine. I do not see any kind of like leakage or anything else that's out of the ordinary with this power supply. So let's reinstall this. While reassembling this, I'm looking here at this thing. Notice there's actually caps in there. There's two going to earth, but it says here that they're Y caps, and there's one there between the hot and the neutral. If those blow, this thing is really impossible to open up. It's all kind of like welded together or soldered together. If you have a cap in there that blows, which I have, I think on my Compact Desk Pro, it did, and it let out the smoke. I could tell because it just was faintly coming out of there. Then I would recommend you just leave it, because those caps are blown open, so it doesn't matter. Or you could just buy an entire new thing of these. These are still available, still standard size, even though they've been used for so long in these machines. The opening, the holes and everything, it's all somewhat standard. All right, and now to try to get this wire thing on here. These are such a pain. I'm assuming with the right tool, it's easy. There we go. This thing makes it a little easy. It's on there. That wire is not coming out. But, oh, these are always so frustrating. There we go. There we go. That is one power supply for the Apple IIe with no more Rifas that are going to cause an issue for me. Goodbye. All right, I have the power supply on the bench here. I even put the cover on just to make sure that this does work. Connected to the motherboard. If you do this type of thing, do not power this up. Unless you know what you're doing, don't plug in mains into a power supply with the cover off. It's very dangerous. All right, RetroTink is connected. I have it up on the screen. Let's turn this on. And there it is. So this test pattern, or whatever you want to call it, is normal for an Apple IIe when you have the keyboard disconnected. And that's because when you power it up, the diagnostics, this is not really a diagnostics, not with this old motherboard, but it's just this sort of pattern it's doing, happens when you hold down Open Apple and Closed Apple, both Apple keys. And those two keys on the keyboard are exactly the same as the two joystick buttons, which I'm pointing to right here. And I think when the keyboard's not connected, those two inputs are pulled high by, something on the motherboard. So I'm gonna try to pull those low. And I brought up some schematics really quick, and yeah, it looks like the two joystick inputs here are pulled high when you push the button. When you're not pushing the button, they are held down at ground with 570 ohms, according to this, this joystick connector at least. And I'm assuming on the Apple IIe, the keyboard itself is also doing that. So I'm gonna use a resistor. I just happen to have one sitting on the bench. I don't even know what value this is. And I'm gonna connect joystick button 2 to ground. So ground is pin 8, and there is push button 0 and push button 1. Push button 1 is pin 3. Okay, all right, I think that should do it. Let's turn this back on. And check it out, totally worked. Apple II prompt, and it's you can tell it's the old ROM because it would have //E for the Apple IIe, but the old unenhanced Apple IIes have Apple II with the brackets like the Apple II Plus, but with lowercase. It's been a couple of minutes and no magic smoke has come out of this thing, or the power supply has been working fine. So I'm gonna say that this thing totally works properly. Now, I won't know for sure until I run some full diagnostics. I don't have a keyboard handy, so I can't really do too much on here, but this thing does seem to be working properly, and if any issue exists, I'm gonna wager that it exists with this empty RAM here, if there's a RAM problem, which would be found with a proper diagnostic. But as it sits right here, that built-in ROM thing we saw when I first turned it on without this resistor, that wouldn't tell us if the RAM was bad. That just does that thing. It doesn't really do anything. So with that, let me put the cover of the power supply back on, and then I'm going to try some of these sweets right here. Power supply is all back together, and I stuck a label on there just so I know that I swapped out the caps and I don't have a dangerous Rifa situation going on in there. Well, all right, let me just quickly try one of these sweets here. We got maple, vanilla, and nut goodies. So nut goodie I think I've had before. One of my other viewers sent in some stuff from Minnesota, and I'm pretty sure these were in there, and that was delicious. So I'm gonna try this bun from Pearson's here. Assume it's chocolate and bad for me or whatever. There it is, a load of milk chocolate with some deliciousness on. Oh yeah, that's really good. Look at that, some marshmallow, some like peanuts or something in there, milk chocolate. It's very rich, very decadent, pretty yummy. A nice vanilla taste as well. I like it. So thank you very much, Mr. Flintstone, for sending in this stuff. Pretty awesome to have a spare Apple IIe motherboard and a working power supply as well. Because I think all those 2Es I've shown on the channel, I think at least a couple of those aren't turning on, so they need replacement power supplies or fixed power supplies. So it's always good to have a spare on hand. And that is going to be it for this mail call episode. So if you enjoyed it, thumbs up. If you didn't, you know what to do. I want to thank my patrons. Their names are scrolling up the side of the screen over here. If you want to become a patron, you can do so at the link in the description below. And subscribe to the second channel. That really helps me out. And I think that is going to be that. So stay healthy, stay safe. I will see you next time. Bye.